Okay, here we go. We got Unit 11, Worksheet 3A. These are going to be the video solutions to the assigned problems, and keeping with tradition, I'm just going to do every other problem. Okay, so in numbers 1 through 6, we're going to rewrite using the imaginary number I, and you can see at number 1, we have the square root of negative 36. So whenever you have to find the square root of a negative number, the first step that you want to do in the problem is you want to rewrite this problem as the multiplication of two square roots. The first square root, you're going to take the number and just put its positive value, so positive 36. And then the second square root, you're going to always make it negative 1. Okay, now this works because 36 multiplied by negative 1 would give me negative 36. And then what we're going to do is we are going to find the square root of each individual square root. So what's the square root of 36? Well, that is 6. And technically, remember, it's not just positive 6, it's positive or negative 6. And that's going to be times, what's the square root of negative 1? Now remember, by definition, the square root of negative 1 is the imaginary number I. So the square root of negative 1 would become I. So this answer becomes positive or negative 6 times I, and we would just write that as positive or negative 6I. Okay, there's number 1. Moving on to number 3, we want to rewrite this using the imaginary number I. So we have the square root of negative 1. So once again, the strategy is we're going to rewrite the problem as the multiplication of two square roots. The first square root, we're just going to take the positive value of this. Remember, we called this the radicand. So that's going to be a positive 1, and then we're going to multiply it by negative 1. Now once again, that works because 1 times negative 1 is negative 1. And then we're going to find the square root of each individual radical. So what's the square root of positive 1? Well, that is 1. And remember, it's not just 1, it's positive or negative 1. Times, what's the square root of negative 1? Remember, that is your imaginary number I. So my answer would be positive or negative 1 times I, which we could just write as positive or negative I. Notice you don't have to write the 1 there, okay? Because it's implied that there's a coefficient of 1 in front of the I. Okay, number 5, the square root of negative 12. So my first step, once again, is I'm going to rewrite this as the multiplication of two square roots. Inside the first square root, we're going to put positive 12. Inside the second square root, we're going to put negative 1. Okay, now when we get to this problem, when you have the square root of 12, this is not a perfect square root like 36 was or like 1 was. So what we need to do is you need to simplify the square root of 12. Okay, now do not just type in the square root of 12 and put down a decimal value for it. What I want you to do is I want you to actually make the factor tree of 12. So I'm going to go over here and I'm going to make the factor tree of 12. Okay, so 12 branches out into what two numbers that multiply to make 12? I'm going to say 4 and 3. You could say 6 and 2. It's not going to matter. And you're going to keep factoring each branch until you can't factor anymore. So 4 can be factored into 2 and 2. So, and then we stop at 2 and we stop at 3. So that means when I simplify the square root of 12, it is going to become the square root of 2 times 2 times 3. 2 times 2 times 3 times, and then this is still going to be the square root of negative 1 for now. Okay, so now I'm going to simplify this. So I have an identical pair of 2's. So remember, you cross them out and you move that to the outside. So this problem, the square root of 12, simplifies to plus or minus 2 square root 3 times, and then the square root of negative 1 becomes the imaginary number I. And then when I multiply these two together, I would get plus or minus, and now we're going to take the I and we just move it next to the 2. So it would be 2I square root 3. That would be the proper way to write number 5. Okay, all right, number 10, we're going to find the sum of number 10, and then we'll do number 12, we're also finding the sum. So remember in number 10, when you're finding the sum or the difference, the first thing you want to do is you want to rewrite the problem without parentheses. And the way you do that is you take the number in front of the parentheses, which in number 10 is a 1 in both cases, and you distribute it so you can rewrite the number or the problem without parentheses. Okay, so I'm going to go 1 times 7, which is 7, plus I'm going to go 1 times 4i, which is 4i. Then I'm going to go plus 1 times 3 is 3. And then I'm going to go 1 times negative 5i, which is negative 5i. And then after you rewrite the problem without parentheses, then you're going to combine like terms. So let's start with the 7. Is there anything that's considered a like term with the 7? Yes, the plus 3. Combine those together and you're going to get 10. Okay, then let's go to 4i. Is there anything that's considered a like term with the positive 4i? The answer is yes, it's minus 5i. We're going to combine those together, so 4i's minus 5i give me a negative 1i. And you could just write that as minus I. So that would be the answer to number 10. 10 minus I is what number 10 simplifies into. Okay, when we get to number 12, we're going to do the same process. So number 12 is an addition problem, as indicated by this plus sign here. So once again, the first thing that I'm going to do is I'm going to rewrite the problem without parentheses. So I'm going to distribute the 1 into the 8. So that's going to give me 8. And then I'm going to distribute the 1 into the positive 3i, and that's going to give me positive 3i. Then I'm going to go to the next parentheses, and I'm going to distribute the positive 2 into the 12, and that's going to give me positive 24. And then I'm going to distribute the positive 2 into the negative 8i, and that's going to give me negative 16i. So once you rewrite the problem without parentheses, your next step is you're going to combine any like terms, if there are any. So let's start with the number 8. Is there anything that's a like term with the 8? Yeah, the plus 24. Combine those together. 8 plus 24 gives me 32. Then let's go to the 3i. Is there anything like with the 3i, the positive 3i? Yeah, the minus 16i. So we're going to combine those. So positive 3i minus 16i is negative 13i. And you cannot combine the minus 13i with the 32 because the 32 doesn't have an i. So therefore, number 12, this is what the sum of number 12 works out to be, 32 minus 13i. Okay, moving on to number 17. Now you notice in number 16 through 21 and 28, we're now going to be multiplying. Okay, so in number 17, we're going to take 12i and we're going to multiply it by 4i. So the first thing we do is we multiply the coefficient, the numbers together. 12 times 4 gives me 48. And then I multiply the i's together. So I times I gives me I to the second power. Remember, each of these i's has an exponent of 1. And when you multiply, the rule of exponent is you add. Okay, so now we need to remember that anytime you see an I squared in an expression, you have to change it to negative 1. So remember, you guys, that the I squared expression, the imaginary number to the second power, is always replaced by negative 1. And then I to the fourth power, and we'll get to one of those in a second, you always have to replace any I to the fourth with positive 1. This had something to do with the I wheel that we talked about in our previous lesson. So this problem, which says 48 times I squared, really means 48 times negative 1. You have to replace negative 1 with I squared. So this is equal to negative 48. So there's number 17 is negative 48. Okay, number 19. We're going to multiply 2i times 5i times 8i times 10i. So first thing we do is we multiply all the coefficients together. So 2 times 5 is 10. 10 times 8 is 80. 80 times 10 is 800. So I'm going to get 800. And then I'm going to multiply all the i's together, and that would give me I to the 4th power. Okay, so when I multiply these together, I get 800i to the 4th power. Now we have an I to the 4th power. So remember, the mathematical rule is that I to the 4th power has to be replaced by positive 1. So this problem, which means 800 times I to the 4th power, really means 800 times positive 1, which is equal to 800. So there's number 19. Okay? All right, last problem that we're going to go over is number 21. So in number 21, we are multiplying the binomial 2 minus 3i times the binomial 2 plus 3i, and you can see that I set it up for you here to multiply the two binomials together. We use the strategy of, we're going to use what we called the magical rectangle in class. Okay, so, and what we're going to do is, we're always going to take the left side and the top of each rectangle, we're going to multiply them together. So for instance, in this top left rectangle, we're going to go 2 times 2, and you're multiplying, so this top left rectangle would be 4. To fill out the top right rectangle, I would take the left side, which is 2. I would multiply it by the top, which is positive 3i. 2 times 3i gives me 6i. To get the bottom left rectangle, I would take its left side, which is negative 3i, and I would multiply it by its top, which is 2. So negative 3i times 2 gives me negative 6i. And to get the bottom right rectangle, I would take the left side of it, which is negative 3i. I would multiply it by the length of the top of it, which is positive 3i. So negative 3i times positive 3i gives me negative 9i to the 2nd power. So then your answer to number 21, what this multiplies out to make, is the combination of all 4 of the rectangles excuse me, added up. Okay, so your answer would be positive 4 plus 6i plus a negative 6i plus a negative 9i squared. Okay, and that would be your final answer if you cannot combine any like terms or simplify anything. And you should hopefully see that, okay, so first of all, there's nothing right now that I can combine the 4 with. However, I can combine the positive 6i with the negative 6i. As a matter of fact, those would cancel each other out. Okay, and then what you can do is also is if you notice, we have, that would leave us left with 4 plus negative 9, but remember, I squared, you have to change to negative 1. So it would become 4 plus negative 9 times negative 1, which really is just 4 plus 9. Negative 9 times negative 1 is positive 9, which gives me an answer of 13. So number 21 should have been 13. Okay, all right, there we go. There's worksheet 3A.